Welcome back to the PLP Advantage. I get to talk about today the individual row hydraulic downforce system. Hi, my name is Drew Lowry. I'm with the PrairieLand Training Group, and let's review our downforce systems that's available. Not shown is the spring downforce system. It is a good system. It gives us 0 to 400 pounds of downforce from the toolbar, but it's only in the good category because you have to stop the planter to make adjustments. The better downforce system is the pneumatic downforce system on the left-hand side of the screen here. It gives us that same 15 to 400 pounds of downforce, but it is better because I can do this from the tractor cab on any of the planters, on any of the software, on any of the displays that software will play on. And it adjusts all ranks the same downforce. So that's why it's the better system. I think the individual row hydraulic downforce system is the best system because it is hydraulic, but even more importantly, because it is individually tracked on each row. Now you can see we get another 50 pounds of downforce, up to 450 on this one, but it is a very fast system. In fact, it's 58% faster than the pneumatic downforce system shown on the left. In fact, it react up to 5 times per second and change 100 pounds of downforce in a single second. That's impressive. Now, for this individual row to be held accountable, we need the computer that's on each row of the MaxEmerge 5E or the ExactEmerge planner. That, of course, is correlated with the SeedStar 3 and SeedStar 4 software that come along with those different options. So let's look at this planter as we go down through the field, and you can see what I'm saying, how smooth and calm that row unit is running. And a calm row unit is going to have the best opportunity to get that ideal seed trench so that the seed will do a good job of germinating. In fact, I think we're having a rougher ride on the gator than the row unit was there. Shown here is the applied downforce on a field we did in northern Kansas. You can see that we're in the green was in the 200 to 250 downforce range. And in the harder part of the field, we were up in the 300s. But if you look real close right here, there's some lines that are in the 400 range. So like maxed out on our downforce or really close to it. So we were kind of wondering what's going on. So we said, well, let's see how our margin's doing. Our margin, of course, is gauge wheel loading. In fact, I like what it calls it, the gauge wheel margin. And so weight on the gauge wheel was 150. That's a pretty reasonable margin. In fact, over here in this softer part of the field is a 125. But we still had these red lines, and these red lines weren't maxed out downforce. These were nearly zero margin. So we didn't have enough weight on the gauge wheels. We need to be up in this green area, but the rest of the planter was that way. So we were kind of baffled. We didn't figure it out till we zoomed in on the screen, which is very compatible with our Gen 4 display. And when we walked in front of the tractor, guess what? We were running row 1 and 16 in the dual wheel tracks of the combine when it harvested last fall. So we were doing corn on corn, planting between the rows, and rows 1 and 16 were maxed out with applied downforce. Row 14, or excuse me, the ones in the middle, 2 through 15, were happy as a clam, down in this 200 to 300 pounds of downforce. So that proves my point that we have 16 individual planters planting back there, and each row does what it needs to try to maintain that margin. That's exciting. And so you're going to get a better job of planting with individual row hydraulic downforce. Now, to get ready to get that ideal downforce, we need to do some prep. One of the things you all understand from our physics lessons in high school is that oil doesn't compress, but air does. So we need to get rid of that air. So here's the process we need to go through on IRHD equipped planters. Each part of the planter is called a section. At the end of each section are these modules. And let me zoom in here. These module, the ones only on the ends, have these couplers. What you do is you take the protective cap off those couplers, hook the hose that came with the planter, it's called the loop flushing hose, and then what you do, you start the tractor, find a selective control valve, and this is, the drawing I have here is SCB1, doesn't matter which it is, with no hose in it. Put it to continuous flow and full flow, and for 2 minutes run the tractor at high idle. Now, ideally, you should have kind of warm oil, above 120, but that would be nice. It's not required. So shut the tractor off after your 2 minute flushing. You don't need to do them all. You just need to do one unless something else is going on. There's not acting right. So take the hose off, put the covers back on, store the hose for the next time you have to disconnect and reconnect to the tractor. All right. Now what we need to do is a quick procedure that is called the hookup, and we need to get the air out of the rest of the system. So turn the tractor back on, go into my menu, go to the seed star icon, and you're going to come down here to the diagnostics and calibration screen and access procedures. So we're going to need to do the air purge test. We got the air out of the main part of the manifold. We need to get the air out of the row units themselves. So with my engine running, I read my instructions here, and it says we should be above 120. It probably will be by the time you ran it doing the other tests. You begin the procedure, and it says the planter must be stationary, the hydraulic pressure must be above that 2,700 psi, and the engine must be running faster than an idle, basically. So once those all turn green, you can hit select next, and then at that point in time, it'll start the procedure automatically for you. So as the procedure is going, this circle spins, and it starts from the outside and pushes the air towards the center. That's how the oil flows. So as each row passes its tests, it turns green, and eventually all the rows will turn green unless there's something not working right, and then you run the test again, and that usually fixes it. Don't forget to say okay, because even though you had a successful test, it isn't stored yet. Now you also then need to do the valve flush test and the valve test. They would be very similar to the air purge test I just showed you, same process. The next thing we need to do is make sure our individual measuring devices for our margin are set correctly. I use this analogy that when you're weighing your wheat truck on your scales at home, you zero those scales out, don't you? Well, this is the same process. So you start with menu, go to seed star. You're going to go over here to diagnostics and calibrations, and we're looking for that calibration icon. Now, we're wanting to calibrate the gauge wheel downforce sensor. And here's a picture of it up here in the upper right-hand corner. And it lives in the row unit frame shown right here. So the gauge wheel arms are pushing up on it. So it's no different than the scale on your feed truck that is weighing the weight of the feed in the feed truck. So calibration may be necessary if the sensors do not read zero. Well, that's why you calibrate your feed truck too. So begin calibration. This is this is a very quick calibration. Wheel speed must be 0. You must be setting still. Planter must be raised. So when you raise the planter up, the check mark turns green. You hit next. It then does its 0 calibration, and it teaches its computer that all row units are at 0. And then it knows what 0 looks like. So it can then go from that number to what you tell it to monitor. Now that your system is ready, let's talk about operation a little bit. Please note that here on the lower right-hand corner of your screen of my planter details view here, I have set this right now to the active downforce system. Now that's done by touching the on-off button here. And so let's talk about active first. So what are we adjusting here? We're adjusting target margin. So this 100 pounds is that same 100 pounds with our target right here. So downforce target margin. So what we're trying to do is get 100 pounds of weight on the gauge wheels that is going to help make that ideal seed trench that other presenters have talked to you about. Now, the margin is always shown here, but on this line here, you get to choose between a downforce number that you can see on my 16-row planter. My downforce is going to be pretty consistent, so it must be a pretty consistent field. But this downforce margin here, I like to call that average margin. And so one of the things I would propose is that you'll get a more accurate and better seed trench if you use this other choice called ground contact. I call that instantaneous margin. And my analogy is that it's like our digital dash car and pickups. Average fuel economy takes a long time to change. Instantaneous racks quicker. So I propose that you would run on instantaneous or ground contact, and you're going to see if you're not keeping it up in that 90 to 80 to 90%, that you're going to need to apply some more margin or downforce. So that's what I recommend that you run. Now, if your field is very changing, very erratic, if you will, you can take the active downforce and turn it off. And so what that becomes in is set point. Okay, so now notice over here, we're changing the downforce, not margin anymore. So we can dial in whatever number up to 450 on our IRHD units. So the same options are over here. I can monitor downforce. My average margin is shown here. And set point, since we are only concerned about downforce, ground contact isn't actually very useful here. But it is handy if you've got a field with a lot of and frequent irregularities. Now, let's talk about this pause button. Let's say you have a field with just a few ground irregularities. We have to do some math here. First thing we have to understand is that at 10 mile an hour, which is the exact emerged planting speed, that is 15 feet per second. So this system will go from minimum to maximum downforce. The hydraulic system will take 4 seconds. Well, 4 seconds at 15 feet a second is 60 feet. So one of the things that I want you to walk away with is this pause button is going to be valuable if your ground change conditions is a narrower than 100 feet pass, and that's about half the width of the planter in front of the weight bracket on the tractor. That is, even this lightning fast system, it's going to have hard time keeping up with that. So pause can be very beneficial to your planting results. Please consider that. As we wrap up our section today, let's watch how calm this row unit, and you can see in the background, this is the smooth field. But the point is that this row unit is getting consistent downforce, and it is then going to result in ideal margin. So that is exciting. With that picture, I do want to tell you where to look for that ideal seed trench and that ideal margin, and that is with the planter in the ground, and look between the gauge and the closing wheels, because that's the ideal seed trench. You can see my downforce on the gauge wheels, on the closing wheels is pressured up. So in normal planting condition, this is the only place to see if you're doing a good job. And of course, you can look back here behind to make sure the seed trench is closed ideally also.